All right, so we're looking at our center of mass. And first we'll look at number 1. So when we look at number 1, the picture, we have a 1 kilogram mass. Then we have a 1.5 kilogram mass. And then we have a 1.1 kilogram mass. And they tell us that this distance here, and remember, when you measure distances in physics, it's always from center of mass to center of mass, is 0.5. This is 0.25. So it says, find the center of mass of the 3-mass system. So just as always in physics, you always have to have a frame of reference. This is just one-dimensional. It's just the center of mass of the x-coordinate. So what I'm going to do is, because I'm used to using the origin of a graph, I'm going to actually make this, the center of mass of the object on the left, my frame of reference. So I'm going to measure everything from this point. That's my frame of reference. So the center of mass, xcm, is equal to, and I can call these A, B, and C, the first mass times that distance to this point, plus MB times the distance of B. So I'm going to call this A, B, C to this point, and then MC times that distance. Now again, the frame of reference is relative. You can pick your own frame of reference. I'm just used to, because we always have our graph being like on the bottom here, that's what I do, over my total mass, which would be MA plus MB plus MC. So now when I do this, it's going to be 1 kilogram. Now this mass to this distance is 0, plus 1.5 times this, which is 0.5, plus 1.1, and I add these two, 0.75, over my total mass, which would be 1 plus 1.5 plus 1.1. And that's just now my X center of mass. And that's it. So that was number 1. Now you can also have, if it might have like a Y component. So usually on the AP test, I would say that if they're going to have a problem, most of the ones I've seen have had both an X and a Y. So you would have to first do the X, then you would have to do the Y. All right, we're going to look at number 7. Now, number 7 is 3-dimensional. It's both X, Y, and Z. But number 3 is a little bit different. It looks at how you're going to approach it. So if we look at number 7, if you look at the picture on the sheet here, here's the picture. You have an X, you have a Y, and then you have a Z. The key to this is I'm always used to using the bottom left, kind of like the origin of a graph. Another thing is that if you read this problem, it says a lightweight pallet has a load of identical cases of tomato paste. So they have the same mass, each of which is a cube. So now if I look at the Z direction, instead of looking at it this way, what you're going to do is you're going to look at this from the top view. So pretend you're looking at the boxes of tomato paste from the top, like you're looking down from above. And when I look down from the above, here, there's 3 boxes. So this would be 3M. So you see how now I know what the mass is and the X and the Y? Does that make sense? So I kind of eliminate the Z because they're the same. Here I would have M because there's 1 box. Here's 1 box. I have 2 boxes, so it's 2M, 2 boxes, M, and then there's nothing here. So this is now my X and Y from looking above. So again, you pick the frame of reference. I mean, you're going to pick a corner. I would do this just because I'm used to doing the origin of a graph. Sometimes most people would probably do this corner, and the reason they would do this corner as their frame of reference is, do you see how most of the mass is closer to this end? Does that make sense? I'm just going to do this corner because I'm used to it. All right. So what I'm going to do is first I'll start off with the X center of mass. So I'm going to do each mass in the X direction. Well, my X direction goes this way. This is my frame of reference. Now, when I find the distance from each of these boxes, I don't do it from the edge. I do it from the center of mass, which is like this. So if each box is L, from here to here, that's going to be L over 2. So when I add it up, this first box is going to be 3m times L over 2, plus this box, which would be m times L over 2, plus this m times L over 2, plus this box, which is 2m. Now this distance is going to be here, so if this is L, and this is L over 2 again, it's going to be 3L over 2, plus m times 3L over 2. Now I'm on these boxes. So this is my distance here, so I have 1, 2, and a half, so that's 5 halves, plus 2m 5L over 2 plus, and that's it. And then that's all the numerator. And the bottom is, I would add these up. So 3 and 2 is 5 and 2 is 7, 8, 9, 10. So the total mass on the bottom is 10m. Okay? So I take each individual box, and then that's the mass. So this is like MA times the distance from the center of this mass to what is my axis. Okay? So 3m times L over 2, m times L over 2, and then m times L over 2, 2m times 3 halves L, m times 3 halves L, and then 2m times 5 halves L. When I add all that up, my X center of mass is 6/5 L, which comes out to be 1.2 L. So that's just the X part. But now I have to find the Y part. So now for the Y part, this is my frame of reference. So the Y I'm measuring this way, right? The X I measured that way. Because remember, I'm kind of just using what I did in the graph like that, because that's what I'm used to doing. So it's easier to do what I'm used to. But you have to be careful, because on the AP test, you have to see what are they using for the reference point. So you have to be careful when you read it. I'm going to do the same thing, and the Y center of mass. So now I'm going to start again with Y and this way. So I'm going to measure these on the top. These on the top, which way? Right here, I m times L over 2. That's this one. Plus m times 3 halves L, plus m times 3 halves L, plus 3m times 5 halves L, plus 2m times 5 halves L, plus 2m times 5 halves L. So what I'm doing is I'm taking each box times the distance to that point, all over 10m. What I would do mathematically was, and that's what I did on the first one, I looked at the ones that had this. First I combined these, then I combined these before I then combined them all. You know what I'm saying? Like I said 3, 4, 5, so I said 5m L over 2 plus 3m 3 halves 3L over 2 plus that, and it made the math a little bit easier. So YCM is equal to 2.1 times L. Now you have to be careful, because they might say find the center of mass from the bottom left corner, but what if they said find the center of mass from this was your frame of reference? So just be aware of what your frame of reference is in case they say what it is. Does that make sense? And if they don't, then you should say this is my center of mass from the bottom left-hand corner. So that was a 3-dimensional, but again, we took the 3-dimensional and we made it 2-dimensional from looking at it from the above, because each box actually had the same mass, so it made it a little bit easier. They're not going to give you a 3-dimensional. but it just gives you a perspective on how to approach certain types of problems, how you can take something that might look a little harder and actually make it easier. And that's it.